In this video, I'm going to go through the Chapter 5 final review. These ones, I want to solve these equations. The first thing I want to do here, since I have a fraction of 1/3, I want to multiply both sides by 3 to cancel out that fraction. That leaves me with x cubed equals, I don't know what 72 times 3 is, 216. Then I want to go ahead and take the cube root of both sides. So I can go math, and then choice 4 is my cube root. 216 gets me 6. So here x equals 6. Same idea for number 2. I want to multiply both sides by 4. I get x to the 4th equals 64 times 4, which is 256. And I can again find my 4th root to get rid of my exponent. I can go math, and then on this one, since it's a 4, I want to choose choice 5, type in the little 4, and then go 256. This gets me 4, but because I personally took the 4th root, remember this means I'm going to get a positive and negative 4. So whenever my exponents are even, I should have 2 roots. Okay. On number 3, I want to start off by adding the 8 first. So I have 1/2 equals 108, 1/2 x cubed. I want to get rid of my 1/2, so I'm going to multiply both sides by 2. X cubed equals 216. The cube root of 216, this part is exactly what we did in number 1, so x equals 6. Number 4, I want to add the 25 to both sides. So I get 5x cubed equals 3,125. Then I want to get that 5 away, so I'm going to divide both sides by 5. I get x cubed equals 625. Then I want to take the cube root of both sides. Which gets me, I'm going to round to 2 decimal places, it doesn't say, 8.55. One answer because my exponent was odd. This next one I want to subtract 4. I get 3x to the 5th equals 96. I want to go ahead and divide both sides by 3. X to the 5th equals 32. I want to take my 5th root. So on my calculator, I'm going to go math. Choice 5, type in the little tiny 5, and then type in the 32. My answer here is 2. And I only have one of these because my exponent was odd. These ones want me to describe the transformation. It gives me a vocab bank. On this one, I have a +4 inside the radical, so this means it's shifting left, right. I mean, shifting left 4. Over here, this one has a number subtracted on the outside, so that means it's shifting down 3. This one has a number on the inside, so that's going right 2. And the 3 on the outside is moving it up 3. This one has a negative on the outside, so that is a reflection. And then the 5 at the end is shifting up 5. Oh, the reflection, I should say, is over x-axis. Over here, I have the negative up front, so that's a reflection over x-axis. The 2 is a vertical stretch of 2. And this 2 is shifting left 2. And the -3 at the end is down 3. Over here, this 3 is a vertical stretch of 3. This negative on the inside is a reflection in the y-axis. So negatives with the x are y-axis. These ones want me to simplify. I can rewrite this as an exponent of 1/3. So I want to distribute my exponent to all of my terms. The numbers and letters are each an individual part. So I have 32 to the 1/3, m to the 4/3, and n to the 5/3. Remember, if I have a whole group, I want to take it out. So I'm going to factor tree my 32. So I have one group of 2's I can pull out. 4 is more than 3, I can pull out an m. 5 is more than 3, I can pull out an n. And I'm going to turn it back into a radical. I have 2 left over 2's, so that gives me 4 on the inside. 4 minus 3 gives me 1m. 5 minus 3 gives me 2 n's. So this is my final answer here. Same thing over here. I'm going to rewrite this. So I have 1 over 81 c to the 4th d to the 5th to the 1/4 power. I'm going to distribute that exponent. So I have 1 over 81 to the 4th power, 1/4 power. C to the 4 over 4 power, and D to the 5 over 4 power. If I type in 1 over 81 to the 4th power on my calculator, 1/4. This one gives me a nice fraction, it's 1/3. C to the 4 over 4 is just C. And then I can pull out a D because 5 is larger than 4. I have 1 D left over that stays under the radical. These ones want me to add, subtract, or multiply. So first I want to see if I can find the square root of 49. It's 7. Square root of 100 is 10. This one gets me 17. Over on number 13, in order to add them, they need to have the same numbers in the radical. So I'm going to try and factor 12. I can pull out a pair of 2's. So my first term stays the same. I'm going to still have that 4 on the outside, but now I'm multiplying by 2. And I have that radical 3 left over on the inside. 4 times 2 is 8. And then I want to add my outside numbers. So 2 plus 8 is 10. Square root of 3. Same thing here on number 14. I already know the square root of 12 from number 13. So that is 2 square root of 3 minus 2 square root of 3. And then I want to factor tree 108. So I get 2 and 54, 2 and 27, 3 and 9, 3 and 3. So I can pull out I could pull out a pair of 2's and a pair of 3's. And I have a leftover 3. So when I go to combine, square root of 2 minus 2 square root of 3 minus 2 square root of 3 cancels out. 2 times 3 is 6. So I have 6 square root of 3 left as my final answer. Number 15, I want to simplify this, so I'm going to factor tree 45. That one I could pull out a pair of 3's. So 3 on the outside, 5 on the inside. And then I want to do the same thing for 80. I can pull out a, oops, 3. I can pull out 2 pairs of 2's. And I have a leftover 5 on the inside. So I have 8 square root of 5 minus 3 square root of 5 minus 4 square root of 5. And I want to combine. So 8 minus 3 is 5, minus 4 is 1. So I just have square root of 5 as my final answer. Number 16, because they're multiplying, I can multiply these together. So I want to multiply the 2 outside pieces together. That gets me 140. And then the inside pieces get multiplied together. 30 times 6 is 180. And now I want to factor tree the 180. So on this one I get a pair of 3's and a pair of 2's I can pull out. So I have 140 times 2 times 3, and then I have a leftover 5. gets me 840 on the outside. Square root of 5 on the inside. Same thing over here. I want to multiply the insides of my radicals. So 2 times 6 gets me 12. With my letters, I add the exponents. So a to the first plus a cubed is a to the fourth. B squared plus b squared, or times b squared, I add them to get b to the fourth. Then with 12, I know that the square root of 12 simplifies to 2 square root of 3. And if I take each of these individually, remember, my square root is the same thing as saying I have these to the power of 1/2. So I really have a to the 4 to the 1/2 and b to the 4 to the 1/2. So I really have 2 square root of 3 times a squared times b squared. So that gets me 2 times a squared, b squared, square root of 3 for my final answer there. These next ones want me to solve. So I'm going to start off by adding 12 to both sides. I get 3x squared equals 12. And divide by 3. X squared equals 4. Take my square root. Because I'm the one drawing the square root, I get two answers. I get x equals plus or minus 2. Over here, I want to start off by squaring both sides to get rid of my fraction x on it. So I have 3x minus 2 on the left equals x squared. I want to rewrite this so it is all on one side. I'm going to subtract the 3x, add the 2. Get x squared minus 3x plus 2 equals 0. I'm looking for what multiplies to 2 and adds to negative 3. That's x minus 1, x minus 2 equals 0. Take my factors and set them equal to 0 using the zero product property. Which gets me x equals 1, x equals 2. I just need to check to make sure that they work, so if I plug them back in, I'm going to just plug them into my calculator. 3, oops, this should be in parentheses, 3 times 1 minus 2 to the 1/2 power should give me back out 1. This one does. I'm going to do the same thing with 2, and it should give me out 2 as an answer, which it also does. So both of these are answers. Same thing here. I want to start off by squaring both sides. So I get negative 6x minus 5 equals x squared. I want to move it over to the other side. I add 6x, I add 5. You get x squared plus 6x plus 5 equals 0. Then I get, if I factor x plus 5 times x plus 1 equals 0. I want to set my factors equal to 0 using the zero product property. It gets me x equals negative 5, x equals negative 1. So I want to plug these numbers in. Negative 6 times negative 5 minus 5 to the 1/2 power gives me positive 5. I plugged in negative 5, so that one doesn't work. Then I'm going to do the same thing for negative 1. Oops. Which gives me positive 1. Both of these don't work, so I'm going to say no solution. Okay, on the next one, I want to go ahead and square both sides. I get 8x plus 20 equals x squared. Subtract 8x, subtract 20. I get x squared minus 8x minus 20 equals 0. This factors to x minus 10, x plus 2. Using the zero product property, I can set those equal to 0. I get x equals 10, x equals negative 2. So I want to plug these in. Oops. That one I plugged in 10 and I got out 10, that's good. And then I'm going to plug in the negative 2. That one I got a positive 2, so that one's not good. So only 10 is my answer here. Same thing on this last one. I want to go ahead and square it. I get x squared equals 8x minus 16. Subtract the 8x, add the 16. So I'm looking for what multiplies to 16 and adds to negative 8. That's negative 4 and 4. I only have to set this equal to 0 once because it's the same thing. So I get x equals 4. And I just want to check this one. Which gets me 4, so this one works. I plugged in 4 and I got out 4. These next ones want me to solve again, so I want us to start off by subtracting. Get 15, I want to divide both sides by 3. Square root of x minus 7 equals 5. I need to get rid of my radical, I square both sides. X minus 7 equals 25, add 7, x equals 32. On these ones, I need to check to make sure it still works. So I want to do 3, and then the square root of 32 minus 7 plus 5, and this should equal 20, because the other side of the equation equaled 20. So it did, I'm good. Same thing here on number 19, subtract 4. So I get square root of 2x equals 4. Then I want to square both sides. I get 2x equals 16. Divide both sides by 2. X equals 8. And then I just want to check this one on the calculator. So I have the square root of 2 times 8. And then arrow out, and plus 4 equals 8 like it should. Over here, subtract 2. Square root of 3x equals 3. Then I want to go ahead and square both sides. I get 3x equals 9. Divide both sides by 3. X equals 3. Go ahead and check my answer. So square root of 3 times 3 plus 2. Oops, that plus 2 should be outside. Equals 5. I've done it right. Okay, still solving over here. So I want to go ahead and subtract 7 on both sides. Square root of 1 minus 5x equals 9. I want to go ahead and square both sides. 1 minus 5x equals 81. Subtract 1. Negative 5x equals 80. Divide by negative 5. Gets me negative 16. And then I want to go ahead and plug into the calculator. I get 16, which is what the equals. Over here, I want to start off by adding 4. Oops, x equals 3. Then I want to get rid of my fraction, so I'm going to multiply both sides by 2. Then I want to square both sides. And I want to isolate my variable, so I subtract 3. I get x equals 97. So I want to check this. I'm going to go second, 97 plus 3, divided by 2 on the outside of the radical, and then minus 4 equals 1. I've done it right. These ones are giving me different functions, and it wants me to perform the operations. So I have f of x plus g of x, so I'm adding the two functions together. So just write it in standard form. I have x squared plus 2x, and then I combine the two numbers together, minus 13. This one I'm adding f of x and h of x. So I have 2x minus 3x gives me negative x. Negative 4 plus 7 gives me 3. I'm adding f of x and k of x. I'm just going to write that as it is. So that looks good. Then I have h of x minus f of x. So when I subtract, I want to put the function in parentheses. And I want to go ahead and distribute that negative. So I have negative 3x plus 7 minus 2x plus 4. And then I go ahead and combine like terms. Gives me negative 5x plus 11. G of k of x, that means plug in the function k of x into my g for x. So I'm going to have negative square root of 4x squared minus 9. Negatives getting squared turn positive. Radicals turning squared cancel out. So I'm just left with 4x minus 9. F of h of 1. So I'm going to plug in negative 1 for my x in h, and I'm going to plug that in for my x in f. So 2, and then, so this is the f function. Then my h function is negative 3 times something plus 7. I'm going to plug in the negative 1 into that. And then I just want to simplify. So I have negative 3 times negative 1 is positive 3, still plus the 7. 3 plus 7 is 10. 2 times 10 is 20. 20 minus 4 is 16. These ones want me to find the inverse functions. I just switched my x and my y. Remember, f of x is the same thing as y. So I'm going to have x equals 15y minus 1. And then I want to solve for y. So I'm going to add 1 to both sides. X plus 1 equals 15y. Divide both sides by 15. I get y equals x plus 1 over 15. I want to write this with my inverse notation because it gave me the function notation. Same thing over here. I'm going to have x equals 1/4 y minus 2. Start off by adding 2 to both sides. X plus 2 equals 1/4 y. I'm going to get rid of that fraction out front, so both sides get multiplied by 4. I can distribute. That gives me 4x plus 8 equals y. Write it with my inverse notation. Same thing over here. I'm going to have x equals 2y cubed minus 5. Add the 5 to both sides. Then divide both sides by 2. And then I want to get rid of my radical or my exponent, so I make a radical with 3. So y equals radical 3, x plus 5 over 2. This whole thing is inside the radical. Then I just write it with my inverse notation. And last one, I switch my x and my y. I want to get the y out of the denominator, so I'm going to multiply both sides by y minus 2. I want to get that x away from the y, so I'm going to divide both sides by x. Then I want to add 2 to both sides. And then just write with my function notation.